All right, this is video 2 in our final review series, okay? So these are going to be those 2A problems, unit 2A, where we dealt with simplifying our radicals, okay? So this is when we broke things down with the factor tree as far as they would go, and that's what we're going to be doing today as well. So little review before we talk through all of these. When we add and subtract, we have to have what are called like radicals, okay? Meaning that they have the same insides and the same index, okay? So if we look here at these 4 problems, A, B, C, and D, that it's asking us to do, the last 3, so B, C, and D, are all adding and subtracting problems, okay? Meaning that they have to have the same inside and the same index. But then we talk about multiplication division problems. Those only had to have the same index, and those are when we multiplied outsides with outsides, insides with insides. So we're going to start with that one just because it's first. And again, that's a closed dot, which means multiplication. So we multiply outsides with outsides, insides with insides. That's the first thing we do. Don't try to simplify these first. There's no reason to do that because you'll still probably have to simplify at the end, okay? So we are going to start with the outsides. Well, if I look, I got an invisible 1 times an invisible 1. That's just also 1, okay? I don't necessarily need to write that. I can, but I'm not going to. I do see that I have the same index, so I'm going to keep that. And now I'm going to multiply the insides times the insides. So let's do it. 8 times 5 is 40. X squared times x squared. Well, those are the same variable. When we multiply like variables, we add the exponent. So 2 plus 2 is 4. And then same thing with the y's. Y squared times y. Well, if it's just a plain old variable, it's got an invisible 1 as its exponent. So 2 plus 1 gives me y cubed. Okay, we're not done yet, though. We still have to simplify the answer. Have to simplify the answer on these. So multiplication, easy in the beginning, but we got to simplify at the end. Okay, so let's do it. Factor tree this. Any two numbers that multiply to 40. So the first things that come to my mind are 4 and 10. If you picked other numbers, that's fine. Keep going. 4 breaks down to 2 and 2. 10 breaks down to 2 and 5. There we go. Okay. So now we're looking for groups of 3 of the same thing to break out of this jail. Okay. So if I look, got a group of 2, perfect. That's breaking out. Okay. We have 4 x's, again looking for groups of 3, so that's one group of x to the first, that's breaking out. We have 3 y's, one group of y, that's breaking out, okay? Then we ask ourselves, who's left in jail? Make sure we keep the same index on the jail. Who's left? Well, if I look, I got a 5, I got an x, that's it. I don't have anything else. So that's my final answer. I'm done. That's it. So that is the process of multiplication. Same index, then we multiply outsides with outsides, insides with insides, and we simplify. Okay, moving on now. We said adding and subtracting is different. Gotta have the same insides and the same index. So if I look, these do have the same index, invisible 2, right? Okay, I don't need to write that. I just know these are square roots, so they both have an invisible 2 as their index. But these definitely don't have the same inside. There's no way, okay? So these are the ones where I have to break it down all the way and then ask myself, do they have the same insides now? Okay, well, I can tell that these are not simplified. So I've got to break them down all the way. So that's what we're going to do first. Okay, so this one we do simplify it in the beginning. Okay, so let's do it. If I look, break down 10, 2 and 5. Okay, break down the x's, break down the y's. If you know that variable shortcut, you don't always have to do this, okay? But I'm just going to do it just to show you. We said it's got an invisible 2, which means I'm looking for groups of 2 of the same thing. Well, if I look, neither one of those numbers make a group, okay? I do have a group of x, I do have a group of y, and I don't have a group of z, okay? So if I look on the outside, 3 is going to stay 3. No numbers are joining him. We just said that. We have one group of x that's joining those two groups of x. So that's going to become x cubed. Okay? And then we have one group of y joining that other group of y, meaning this becomes y squared. Okay? And then who is left in jail? Well, we just said the 2 and the 5 cannot escape, so they're going to stay 2 times 5, which is 10. And that z also has to stay put. Now we're going to do the same thing, but we're going to do the second term. Okay, break down 20. Okay, break down these variables. And now let's see who's breaking out. So if I look, again, still looking for groups of 2. I got a group of numbers this time. And I got 2 groups of y. And that's it. Okay, so I drop down my plus sign. Here on my outside, I have 3 groups of x. That's it. Okay, so we just said a 2 is escaping. He's going first. Numbers first. X third doesn't have anybody joining him, so he just stays the same. We just said we're taking out 2 groups of y. That's y squared and nothing else. So now I pop up my jail. Who's left inside? Well, it looks like we got a 5. And it looks like we have a z. Okay? From here, I would then ask myself, do I now have the same index and the same insides? And if I look, this one tried to trick me, okay? These insides are not the same. I broke them down as far as they could go, but they still are not the same, okay? That means these cannot be added. This is just my final answer. Okay, it's long, it's obnoxious, okay? We think that they should have added together, but in this case, they just didn't, okay? And that's okay. Sometimes they will, sometimes they won't. So, in this case, they won't. I leave it alone, and I move on. This is the same process now, okay? We're just subtracting instead of adding, but the same process is what we just did on the second one. So, do they have the same index? Do they have the same inside? They do have the same index, but they don't have the same inside. Let's break them down. Okay, pause the video. I want you to try this one. See if you can get this one to break down. Okay, so several ways we could have broke down 128. I'm going to break it down as just 64 and 2. 64 could then break down to 8 and 8, for instance. Okay, again, multiple ways that we can break these numbers down. So if your math doesn't look identical to mine, as long as you get the same numbers at the bottom of your tree, should be fine. Okay, so when I'm done with my tree, looks like I have 1, 2, 3, 4, 5, 6, 7 2s. Okay, so as long as you got 7 2s at the bottom, and that's all you got, then you factored this correctly. So don't erase your work if you pick different factors than me. There's multiple ways this will work out. Okay, so same as what we did before. My outside is 8x squared, okay, and we need to see who is joining him. Okay, we're looking for groups of 3 this time. Our index is 3, okay? So let's go ahead and do that. Looks like I've got one group of 2, 2 groups of 2, and then I have 3 x's. So that's one group of x. Perfect, okay? So 8 is being joined by 2 and 2, okay? And then x squared is being joined by one more group of x, making it x cubed. Okay, and then who's left in jail? Looks to me like we just got a lonely 2. That's the only thing left in that jail. Okay, can we clean this term up? Absolutely. We know we can simplify outsides with outsides, insides with insides. So 8 times 2 times 2 times x cubed. That is 32 x cubed, cube root of 2. Okay, the inside will not simplify there. Now we're looking at the second term. So I'm dropping down my subtraction sign, and we're going to go do the same thing over here. So break this down. Well, 2 doesn't break down. 2 does not break down, but x to the 9th sure does. That's 9 x's. So I could go ahead and in my mind group that into 3's because I know how to do 9 divided by 3, or I could visually just circle these out. Okay, that's 3 groups of x that are breaking out of this jail. So already got a 2 on the outside. He stays put. He's being joined by 3 groups of x. And then we still have that lonely 2 on the inside. Okay, that's how we do this. Can we clean this term up? Nope, that's already cleaned up. There's nothing else we can do as far as simplifying outsides with outsides, insides with insides. So now we have these two terms, and we ask ourselves, can we subtract these? Do they have the same index and the same inside? Absolutely. Okay, so we keep that. We keep that index, we keep that inside, and now we are just subtracting those terms, those outside numbers, okay? For instance, don't write this down, but for instance, if I had 7x minus 5x, my answer would obviously be 2x, right? Okay, I'd keep that x. I'd really only be subtracting 7 minus 5, okay, which would give me 2x. So that is essentially what we're doing here. The only thing I'm subtracting are those coefficients, 32x cubed minus 2x cubed. Well, what is that? 32 minus 2 is 30. X cubed. That's my answer. That's my answer. Okay, I'll zoom out here, let you see it again. Again, if you have questions on this stuff, be sure to ask me if it still doesn't make sense after these videos. But we have plenty of opportunity to practice these. We have several days until our final. So just make sure that we are getting this stuff. If it's not clicking, though, you got to let me know. Okay? One more. And again, it's adding. So again, same insides, same index. Make sure you've got them. We obviously don't. So go break this one down. Pause the video right here. All right, here we go. So first term, 64. Break it down. I'm going to do 8 and 8. Then I'm going to break these 4s down. Perfect. Just 1x and 4 y's. Perfect. So we got a 3z to the 4th on the outside. Let's see who's joining him. I'm looking for groups of 2 because this is a square root. So 1 group of 2, 2 groups of 2, 3 groups of 2. So already have a 3. It's being joined by 2 times 2 times 2. It's also being joined by 2 groups of y, call that y squared, and then z to the 4th is already there, okay? Who's left in jail? Well, looks like it's just a lonely x. That's the only thing left, okay? It was this x. He could not break out. Clean this term up. 3 times 2 times 2 times 2, y squared z to the 4th. So let's see, what is that? 6 times 2 is... So 24, y squared, z to the 4th, square root of x. Keep my plus sign, go do it all again on the second term. We break down 16. Got 1 lonely x, we got 2 y's, and we got 8 z's. So, 1 group of y is already on the outside as well. So again, groups of 2, got 1, 2 groups of 2, so 2 times 2. Looks like the x is not breaking out, but we got 1 group of y joining that group of y that's already on the outside, so that becomes y squared. And then we've got 1, 2, 3, 4 groups of z. And again, the only thing left on the inside is just that lonely x. So we clean this term up. 2 times 2, y squared z to the 4th would just be 4, y squared z to the 4th, square root of x. And now we ask ourselves, are these like terms now? Do they have the same index and the same inside? Yes, they're both square root of x, so we keep that. And now we are just adding these coefficients. 24 plus 4 is 28. When we add, we never add exponents, so that's why this is staying y squared z to the 4th. Don't add those exponents. We don't do that. Okay, we didn't do that on the other two either. So like here, x cubed minus x cubed, right? Okay, those are the same. They stay at x cubed. We do not add exponents when we're adding or subtracting. We only add exponents when we multiply, okay? Which we're not doing here. So there we have it. That's how we do this. That's how we do this.